Hello students, this is lesson 19.1 and this is the classwork, so I will be working each question out step by step. Alright, last two times I tried to do this video, it came out to be like 20 minutes long, so I'm going to try to compress it a little bit quicker. So here's how it works. We're going to answer question A, B, C, D using what we learned in lesson 19.1, and what I'd like you to do is every time I say, okay, let's work question number, I want you to pause, you try it, and then come back and then continue playing it to see if you did it right. That way it'll go quicker. All right, so the first one we're going to try is number 1. So go ahead and pause, try number 1, and then come back to it. Okay, so for number 1, we need to answer 4 questions. We need to answer is A, does it open upwards or downwards? B, is it a max or a min? C, is it a reflection across the x-axis? And D, is it a stretch or compression? Please remember, every single one of these equations has the form f of x equals ax squared. And right now we're only interested in A. Okay, so for question A, does it open up or down? Well, it depends. Is A positive or is A negative? If A is a positive, it opens upwards. If A is a negative, it opens downwards. So right now, I can see that A is a positive, so it opens upwards. Now, with that said, we move to the second part of the question, question B. Question B wants to know, is it a max or a minimum? Okay, so we have a maximum. That means it is the highest point of the graph. Where does that happen at? Okay, in order for something to be the highest point of a graph, that means when you graph it, it should look like this. And this point right here would be the highest point on the graph. Now, notice it's opening downwards. So that means you have a maximum when A is a negative. Well, the opposite would also have to be true. So if you have a minimum, then that means the graph is opening up in this direction, which means the lowest point on the graph is right here, which means A had to have been positive. All right, so since A is 4 and it's positive, that means we have to have a minimum. So we're going to come over here and we're going to answer with minimum. Now, where's the minimum happening? Well, it's happening at the origin, because notice the only thing we have is the 4x squared and there's nothing after it. So since there's nothing after it, we say that if I were to put this on the xy axis, and I want to pick a different color. Oh boy, that's pretty. Okay, you notice both of these happened right here. Okay, so I know now that it is at 0. Okay, now we need to know, is it a reflection? Well, pretty much it's a reflection if it goes across the x-axis. Right now, this one is a reflection to this one. So they're reflections. We would refer to this one as the parent graph, because if I look at Desmos, and I graph x squared, remember that's the parent graph. X squared is the parent graph. How do I get it to reflect across the x-axis? Well, there's only one way. Is to do that, and that's it. There's no other way to make it happen. All right, so if that's the case, then when I come back to my worksheet, I could tell you that now this one is not being reflected. Bless you. Okay, now we're ready for the question D. Is it a stretch or a compression? Okay, so for this one, it's a stretch if the absolute value of A is bigger than 1. Now, let me explain this, and I know this kind of looks a little weird, so let's clean it up just a tad bit. Stretch. Make that just a tiny bit. If absolute value of A is bigger than 1. Okay, what does it mean by the absolute value? Remember, the absolute value is a distance a number is from 0, therefore it can never be negative. It has to be a positive answer. So if I look at 4, 4 is bigger than 1, therefore it is a stretch. Okay, so now we have all 4 answers. So now you do number 2, pause. Once you finish number 2, go back to it. Okay, so for number 2, we notice first of all, A is negative. Since A is negative, it goes down, which means we have a, again, remember if it's going down, we have a max. And our maximum is happening at 0, which in this case is the origin. Okay, now, I need to know, is it reflected? Again, compared to the parent graph, it is a negative. So let's take the negative and say it is reflected. So compared to the parent graph, this is reflected across the x-axis. Okay, last question. Is it a compression or a stretch? Now for this one, remember, we don't want -5. We want the absolute value of -5. So if I do absolute value of -5, then I have 5 is bigger than 1, which is a true statement. So this one is being stretched.
There's a text on here from Strum, but it's...
All right, now you try question 3. I'll give you a few seconds. Pause, do question 3, come back. Okay, so for question 3, we have A is equal to a negative, so it's opening down. And if it opens downwards, it has a max. And this maximum is happening at 0. Again, that's at the origin. Okay, now, is it a reflection or not? Well, did you notice it's negative? Therefore, it is a reflection. Lastly, is it a compression? Well, if we were to come over here and repeat this little game and say the absolute value of -3.2, is it bigger than 1? Well, -3.2 would actually be 3.2, and this is a true statement, so since it's true, it is a stretch. Okay, you try question 4. Okay, so for question 4, first of all, you notice A equals a positive. So therefore, this one is a minimum, and it's happening at 0. Is it a reflection? No, because A is positive, it is not reflected. And lastly, is it a compression or is it a stretch? Well, it's not bigger than 1, but it does fit this mode. And you're a compression if, oops, don't want that, keep doing that, and that's not right, can be equal to, has to be between 0 and 1. Now if I do this, 0, absolute value of 0.4, absolute value to 1, then it fits nice and neatly between this, which is true. Since it's true, it is a compression. All right, now we're going to try questions 5 and 6 along with question 7. Please follow closely. Again, I'd like you to hit pause, see if you can get them, and then I'll go ahead and help you out with the answers. Okay, so for question 5, we're looking for the vertex. please remember what the vertex is. It is the lowest point or the highest point on the graph where both ends connect together. So if I were to put a dot right here, that would be my vertex. So the vertex is located at 0, 0. Okay, is it opening upwards or downwards? This one is opening upwards, therefore I have a minimum, and it's located at 0, but I do not have a maximum. Okay, is it being reflected across the x-axis? In this case, no, it is not being reflected across the x-axis. Therefore, this one is no. And lastly, is it a vertical shrink or stretch? Okay, stretch or compression. They're just using the word shrink for compression. All right, so in this case, I notice it is 1.5. 1.5 is in fact bigger than the number 1. So it is a stretch. Okay, you try question 6. Put a pause and then come back to it. Okay, first of all, I noticed that A is negative. If I put a dot for my vertex where they both connect, my vertex is located at 0, 0. A vertex is always an ordered pair. Okay, where is it happening? Minimum or maximum? Is it the highest point or the lowest point? For this one, you notice it doesn't have a minimum, it has a maximum. So none for this one, and this one is happening at 0. Is it reflected? Yes, it is reflected. How do I know? Because A was negative. Now, take the absolute value of negative 2.5. Is it bigger than 1? Well, that would be 2.5 is bigger than 1, so it's true. So yes, it is a stretch. And now comes the last question, question 7. For question 7, we're given an ordered pair, and it wants us to find the value of just A. Okay, for this one, we're going to need this guy. Let's bring him down here. So y equals ax squared. Just so happens that ordered pairs have x's and ordered pairs have y's. Plug everything in. So I have 48 equals A times 4 squared. According to PEMDAS, you have to do the squared first. So 4 squared would be 16. So now you have 48 equals 16a. Remember, coefficient is always in front of variable. Where's your variable? What's attached to it? What's it doing? How do you get rid of it? So we're going to divide both sides by 16. And you finally get your answer of 3 equals A. So I come over here and I say my answer is 3. Hope this helps out. If you have any questions, you could watch it more than once, or you could shoot me an email for a better explanation. Goodbye.